All right, so we've got if the function is increasing, then the first derivative, what are we supposed to know about the first derivative if the graph is going up? What do you think?
It's above the x-axis.
Well, you got to be careful in saying that, because sometimes we look at a function graph, sometimes we look at a first derivative graph, and eventually we'll look at second derivative graph. So above the x-axis means different things at different times.
First derivative graphs above the x-axis.
Okay, so when the first derivative is, what's another way to say above the x-axis?
Positive.
Yeah, positive. That'd be. Well, we also don't always have a graph. So the function is going to be going down if the first derivative is negative. So that was like the first thing I had you write down in your first derivative notes, and I told you it would kind of carry over. So hopefully you guys really learn that stuff well, because that'll make this easier. Okay, if the function had a max or a min, what does that tell us about the first derivative? What would have to be true about the first derivative?
Zero.
Okay. Or undefined. I know the undefined case doesn't come up much, but remember something like a cusp maybe, it would be undefined here, but that's still a min. This was the function. Okay, for a graph to be concave up, second derivative needs to be positive. Concave down is when the second derivative is negative. Again, nothing new here, just kind of putting it all in one nice neat place and reviewing. To have a point of inflection, that's going to happen if and only if the second derivative is 0 or undefined. Possible points of inflection come when the second derivative is 0 or undefined. If the derivative goes from negative to positive, so I'm using this for these two. If it goes from negative, decreasing, to positive, increasing, the graph was going down and then it's going up, then that is going to be a min, at least a local min. Might not be the absolute min, but. And if it was going up and then it's going down, then we know we've got at least a local max. If the first derivative is increasing, so another way to say increasing is that its slope is positive. So if the slope is positive on the first derivative, that means the second derivative is also positive. Vice versa. If the first derivative is decreasing, that means its slopes are negative, and the slope of the first derivative is like the second derivative, so the second derivative would be negative. And if our first derivative has a max or a min, so like right here, what that tells me about the second derivative, well, the slope at that instant is either 0 or undefined. So what I really think you should do right now, I mean, a little bit of it could be that you haven't thought about it in a few weeks, so it's okay if you're a little rusty. But there's a couple of these that you know that you don't know very well. You should really put a star by those right now, and maybe if you can think of a sentence or two to kind of help yourself out. Just identifying those makes this a little bit more useful of a resource. But I would keep that out. This is the stuff that we definitely need to have memorized. So you can refer to it, but you want to refer to it less and less.